problem number 2, we have a circle of radius 2 centimeters, which is cut into 4 equal arcs, and then those arcs are arranged to make this nice little bow tie looking shape. And the question asks, what's the area enclosed by this shape? Okay? So my hint to you would be to look at this shape, figure out what you know about it, and see if you can maybe cut it up into pieces and rearrange the pieces into a different shape. You could try that. If this were a circle, we could put like a little center here, and you could draw a radius like that. You could draw a radius over to this vertex, assume that's a straight line, and you could draw a radius there, you could draw a radius there. Okay, so essentially here, now, if I drew these nicely, these should be 90-degree angles, but so anyway, what I would suggest is to possibly slice this into some pieces and try to rearrange it into a different shape. Okay, so probably the easiest thing to do, which is what I did when I solved this problem, was to slice off, I'm going to kind of draw a dotted line here, slice off these arcs on the edges. Okay, and because we know that all these arc lengths, this arc length and this arc length, this arc length and this arc length are all the same, you know that if you were to take this piece of this shape and slice it off at the dotted line and move it over here, that it should fit right in there. Okay, in the same way down here. If you were to slice off this side, this left side of the shape, and put this piece, it should fit right in there. Okay? And then we're left with a square, right? Because these arcs are the same length. They're made with the same radius of 2 centimeters. So we also know that the distance from this corner to this corner is the same as that from this corner to this corner, or this corner to this corner. So we have a square here. Now what else do we know about this shape? We now have a square, and we know that the radius is 2 centimeters. So this length here, I'm just put one here, 2 centimeters is this radius from out to here. Okay. And we also know that if we took, this one would also be 2 centimeters, and 2 centimeters, and this one is also 2 centimeters. Okay, so you can see, I think you can see, that we have two triangles. Now we could slice it either way, I guess. So we have a triangle that's formed by cutting this square along the diagonal, right? Because we know that this thing within the dotted lines is a square. And if we cut it along the diagonal will be twice the length of the radius. And so we have a diagonal of 4 centimeters, and we have half a diagonal is 2 centimeters. And if you look at this triangle sideways, I'm going to pick up a highlighter, I think. So if you take this triangle, I'm just going to highlight what triangle I'm talking about. So we have this triangle that's half of the square. And we know that the area of a triangle is 1/2 base times height. And so we can actually use this diagonal as the base, and the height is half of the other diagonal. So, and then we can do the same thing over here if we were to highlight, let's highlight that in pink. So we have another triangle down here. Ooh. I'm trying to draw straight. Okay, so we have another triangle here. This other half is a square. And it again has a base of 4 and a height of 2. So, if we add those two triangles up, we get 2 times the quantity, 1/2, base, which is 4, and height, which is 2. Okay, so the area is equal to that. So we have two triangles, that's what this 2 comes from, two triangles that have a base of 4 and a height of 2. So 1/2 base times height. So you can see we can divide the 2 in half there. So we end up with 8. And our units are square centimeters. Alright? So, there you go. There's the area of that bow tie. We took that bow tie and we made it into a square, and then we were able to find the area.